Hey folks, welcome to another episode of ASP.NET Core from Zero to Overkill. In this episode, we're going to add EF Core to add persistence to the application. Right now we have the application using like an in-memory store, if we would call that. Basically, it's a list. We'll be adding Entity Framework Core as a persistence. We're not going too crazy with that. We're just going to do simple stuff to accommodate for what we have today. So along the way, in other episodes, we'll be adding other things. Right now we only have groups, so we'll only store the groups. In the future we'll add more things, so more tables. Right now it will be only one simple table. So probably a simple episode, but with the basics of using EF Core. And along the way, in other episodes, we'll add more things. I think this episode will be like the transition. Right now, until now, we had a lot of just demo stuff, but I think from now on, of course, there will be some exceptions, but from now on, we'll probably be more on implementing the real application and not just talking about loose stuff like in the past, like 5 or 6 episodes. So I will be using Entity Framework Core to access a Postgres database, which I have running on Docker already. It's not mandatory, but I like to use Docker for this because it's really easy to clean up afterwards instead of having to install all databases I want to test. So I'll use Postgres. I started it with this command right here, but if you're interested, then I can leave a link. But you can install it any other way. And okay, continue using this. And to check out the database, I'll be using JetBrains DataGrip, which works well. And for what we're going to use in this episode, it's even too much, but yeah. So let's get on with it. So before really starting to code, I should say that I upgraded the .NET SDK because this past week the 2.2 version came out, so I have already upgraded. Let me just make some changes here to the web project. So .NET Core App 2.2. Should be good. Let me just check. Yep, all good. So beginning with creating a new project to put all this database related stuff, net standard, C#, yeah. Keep in mind this is the simplest or a simple one project structure. It's maybe not the best one, but for what we are doing right now, it's more than enough. So we have the project. Let me just go to the newly created one and add a couple of packages that we need. So we need EF Core, and we need the Postgres provider for EF Core. Okay. I'll create a new folder. Need a group, so let's check out how is the group we created on the business, and we want basically the same. Okay, now let's create a DBContext for the to access our database. Add new class. I'll call it and we inherit from DBContext. Okay, now we need a public DB set of group entity groups. Okay, let me just check my sheets because I don't know all of this by heart. Okay, so to configure this, there are other ways, I guess, but I usually go with this. Get the DBContext options. And we pass it to the base. No need to do anything here. Okay, so we must configure, we created our entity here, and it probably would have worked just like this because of assuming stuff. For example, just because this is called ID, I think Entity Framework would assume it's the ID and make it auto incremental and stuff like that. But we can do is create a directory. There's a little type. We'll create here a entity configuration that will implement this interface that I always forget the name, so I put it here. And implement this. This will basically allow us to configure this entity. Alternatively, and before we had this, we would just go to the DBContext, which we need anyways, and then override on where is it? Oh, protected override. Really? No suggestions on model creating. Sometimes IntelliSense or whatever JetBrains calls it doesn't help. Oh well. Everybody complains about Visual Studio, at least this is similar. Okay, so over here, normally, before we had that interface that I showed you, we would go to Model Builder, Entity, Group Entity, and then start saying something like has key and we said font ID, but this wasn't really great because we had all the entities over here. So now we can just have a configuration per entity and do it over here. So we can go here. The builder is already in the context of the entity, so we can say has key. And then we can say builder and you use this to have a auto-incrementing property, column in Postgres. This is one thing I really don't like that much, because I would say it would be nicer if we could have something generic that every provider would do. So we would say auto-incrementing. So in SQL Server it would use identity. In Postgres it would use this serial column, because doing it this way, it depends on the provider, which isn't great. It's like a leaky abstraction, but okay, it's what we have right now. Another alternative would be to go to, for instance, group entity and say key. I think it's this one, but I'm not a fan of this because we pollute the entities, and probably will do in the future, move the entities to a separate class library, much like in a DDD scenario, where we have the entities separated, just normal POCOs. Then this doesn't make sense because we're attaching the entities to entity framework. Right now it wouldn't be that big of a deal because I'm putting it all together, but if we wanted to do it that way, just have the entities in the class library and then another to join it with the database technology, this would be a nicer way to go. So we have this class cleanup, and then we have something that configures it. Now to use this, we go here to group management, DBContext, and we can go to the builder and apply configuration, and then we can do new group entity configuration. Another thing that I will do, just because I don't even know if I really need to do it, but I'm used to do it because the default schema in Postgres is public instead of DBO like in SQL Server, so normally I do this. This part of apply configuration might be a bit too much. If we have lots of entities, then we would need another line for each. So in that case, maybe do something with reflection to find all implementations of identity type configuration. But right now we have one entity, and I don't want to spend that much time doing the reflection shenanigans. So it will work like this for now. Now that we have this kind of prepared for what we need, at least at the moment, we need to put this in the database. Although not really mandatory from the beginning, because EF is capable of just creating the database on the fly with this information we have right now. Because in the future we'll want to add more and more information, we should go with migrations. So migrations are really a process. I don't know how to call it. It's a way we define how the database evolves. So we'll create an initial migration that represents how the database should be implemented right now, and then a script can be ran on the database creating the table we have at the moment. And then when we add a column or when we create a new table, we add a new migration that adds that information to the existing database. So it's a way to apply this in all environments and all that. So let's create the migrations. One thing that is a bit, I don't know if weird, but okay, it's that we can't create them just using this. Migrations require an executable, for what I understood, or at least something that's not .NET standard. It must be .NET Core app or a .NET Framework app. Because this is just a .NET standard library, we must use another thing. I will use the web application to do that, but for instance, a colleague of mine had the good idea to create like a console application just responsible for running the migrations. It's a nice idea, because when we want to control everything that happens in the database, maybe we don't want it to just happen automatically, and having that application on the side, we can just grab the application, go to a database and run migrations on it. Right now, because I'm keeping it simple, I will use the web application to do that, and when the web application starts, it will run the migrations, at least in development. I will see how I'll implement that, and run the migrations automatically, then so it will always be at the latest when we try to run it. So let's get to it. For starters, we need to go to the web application and add a reference to this data project we created. And then what do we need? We need a connection string. So let me go to the sheets again, because I don't know this. Or I know kinda. So we need a section here called connection strings. We don't need, but it's a way of organizing. And notice I'm doing this in development, because in production, for instance, it would be a good idea to use something like a key store or environment variable to pass these arguments. Right now in development, I could have used that secrets management tool that we talked about when we talked about configurations, but because this is really not very important, I'm just connecting to a local database for this. I'll do this group management DBContext, and we'll have the connection string that I'll copy here. Okay, so I'm putting in the connection strings in development. So localhost, this is the default port for Postgres, and the user ID is user and password is pass, because yeah, more than good enough. So we have this here. Now we go to the program, the startup, and we need to configure something. Should I do this here or in the business? I'll do this here for now. DBContext. And we must configure this. So we want options dot use and be SQL. We could do something like this directly in the DB context, but by doing it this way, the DB context is not stuck to Postgres, although here it is, so it could be better, but maybe we can have better ideas in the future. And now we go to configuration and get the connection string. Okay. I think this is enough. Okay, let's try it then. We are here. Let me clear this up. So what we want to do is .NET EF migrations add, if I'm not mistaken, and I'll call it initial create. If I do it this way, we'll get an error. Okay, so it's .NET standard, there is no runtime, stuff. Start a project. Okay, so let's start the project. We can say web. Hopefully this is enough. What did I do wrong? What value is null? Startup. Did I mess something up? Connection strings. Now I'm confused. What am I missing? Okay, maybe I had an error. Okay, let's see the created migration. So by default, it creates a new migrations folder inside the data project. We can change this output folder, of course, but this is the default. And we go here and see initial create, and it basically has schemas, has the schemas script, but in C#. There's also a way to script this to a SQL file, but we don't need it. So, okay, we have this here. Now, when we run the application, we want this to be run immediately. So we have the database up to date immediately. So we can do is go to program, and instead of doing this immediately, we can go var host equals this. And now we can do something like I'll create something over here. This is just me doing stuff. You can of course do it in several other ways. Okay, why isn't it writing? Today Rider is kind of acting up, I don't know why. It's not the first time. Why can't I write? Well, do the classic. Stop it. Run it again. How about now? Okay. What will we do? So I'm just creating here something. Static task. How did I call it? We get the web host. I could do it in the program, but let's keep it clean. Now, we need some things from the dependency injection, namely the DBContext. So how can we get it? That's why I passed the host over here. The host is built, and with the host built, we have dependency injection container in it. So we can do a new scope, host.services, which is an iService provider, as in the dependency injection container. Create scope. So this create scope is like the scope that is created per request. I'm creating a scope because if I don't create a scope, it can create something that will be like a singleton, and we don't want that. So we'll create a scope, and everything that's created in that scope will be released depending on, of course, its lifetime. If it's really something singleton, it will be a singleton. But if it's transient or per request, when we clean up the scope, it will be gone. So I'm doing this way. And what do we need? We need a context. To access the context, service provider dot get required service. There is the get required service and the get service. The difference is the get service will return null if it doesn't find it. The get required service will throw an exception. We want the DB context. So now that we have DB context, we'll just apply the migrations. So wait context database that migrate async, and we want this, I think. Okay, for now I'll leave it like this, but we could do some logic like only migrate automatically if in development, but no need right now. We'll worry about that in the future maybe. So let's go to program. Now we have this here. Let me check something. Okay, we'll do a little sheet here. We'll go here and change the namespace to this. By doing this, we get automatically this just by using the host. Ensure, yeah, it's like it's a method of it, although it's not. Oh, okay. We need to do async main. If I'm not mistaken, it's just like this. In the past we didn't have this, but now we have, so let's use it. Okay. Let me check something here. I always forget. I don't want 1, I want 3. I think it's the latest, except for the 8 that it's still not finished. Okay. So this is done, I think. Let's try run this. Web. Okay, we see here the migrations were done. So let's go here and do management groups does not exist databases, Postgres schemas. We need to refresh this. Problem with using entity framework and stuff like that, it's sometimes I forget how to write SQL correctly. Why doesn't this check something here? Oh, I'll just create a new stuff database. I have no problem. Group management. Yay. Yeah, now we have it. Okay, so we have an empty table, but we have a table. You can see here that if we go here to the schemas public, we have 2 tables, one groups and one migrations history. So all this information is kept here. So when I add migrations, the entity framework knows from where to start. Okay, so we have this. Now let's replace our in-memory stuff with this. Adding to business implementation. We won't need this anymore, but let's leave it here right now. Now, groups service, which implements groups service, all that stuff. Okay. Now let's do this. We need to add a reference to the database project. we need a constructor to get to DBContext. I'm using the DBContext directly in the service. Won't go with a repository pattern right now. There are some that argue that you should. There are some that argue that you shouldn't. I think you probably should, but depending on the complexity, if it's a really simple application, it probably doesn't matter. But for now, I'll go directly to the context, and then in the future, we'll try other approaches. But right now, just to replace the in-memory stuff we have, we'll go with this. So we need the context, and let's do some things. This will all be async. So in this case, we want every group we have. So we can go to the context.groups dot to list async and pass in the cancellation token. So we want okay. Now we want to return a group, but we have a group entity, so we'll do it like we did in the web project, and we'll create a little mapping stuff. Group mapping. Mapping or mappings? Group mappings. So this will be an internal static class with some internal methods. Let me copy stuff from here, because it will be very similar. Instead of group, this will be called to service. This will be called to entity. So now that I see that, maybe we can do something with this. We don't need this public, I think. If it needs, I'm sure EF will complain. So we have this mapping. Let's create another mapping. But before, we need something like this, but I don't want to put this in every place. Oh, wrong place. Instead of group view model, we want the the in, the out, not groups, output. And we need to get a func that maps the into the out. Okay, I think that's it. Let me just check something here. No. Well, we can do the same for the other one. No, we'll make life easy. Do it like this. Okay, so we need a mapper. And if the input is empty, we return an empty. If not, we map it to an array and all that stuff. So now we can do, let me just, so we could do something like return groups dot map collection. No, we shouldn't do this directly. Read only collection of group. Call it to service as well. Use my read only collection of and we do map collection to service. What? Why? Oh. Okay. Oh, this is right. Now it's good. So this just uses that map collection helper and passes in the to service. So if we go to somewhere, I'm lost. Yeah, over here. We can just to service. Now get by ID. We should do equals. We await on context.groups. What I don't like about find the sync, it is forces us to, if I just did ID, it would work because it has a params object to receive. But then I can't pass CT because it will think that CT is part of the key. So I need to do which isn't really great. The alternative would be do something like ID equals ID. Which are basically the same, but this is a lambda that captures the ID, and in this one we pass it to an array. I have no idea which is best in terms of performance and stuff like that, so I'll go with this just because I don't like to create an array like that. Okay, so we have the group. Now we return now to update. There are a lot of ways to do this. Okay, maybe not a lot, but more than one. So let me, you know what? I'm lost in my sheets. Okay, so probably the easiest one. Why does it do this? Annoying. Probably the easiest way is to just go to context.groups.update, passing the group or group to entity. Which returns an entry, if I'm not mistaken. Yeah, it returns an entry. To get the group entity, we must go here. So this will work probably most of the times. Maybe one thing to keep in mind is that by doing this, if for instance, we had called get all async or get by ID, and then we do this, the entity is already in the DB context, and when we do this way, it will try to add the entity again to the DB context in the modified state, and it can throw exceptions in that case. Probably isn't too bad because we probably won't do that in the same request, so this simple way works, but we could do something else. I'll show you in a bit. But most of the times I think this would work, so no need. So await context.save changes. In the other ones we didn't need to do this because we are only reading. Right now we are writing, so we want this. And then we return the updated entity. So to service. And to add, it's really similar. I don't remember what this returns. Let me check. Groups, add async. Add async is interesting. Okay. We don't really need this because we won't go to the database immediately. So we want group to entity, and it returns a entry. So, like before, await. Save changes async, cancellation token, return, added group entry, dot entity dot to service. Okay, so this should be ready. Now we go to the startup business. We don't want this anymore. We want services dot add scoped. Seems reasonable. And I group service to group service. So in every request we'll get a group service within iGroup service. So right now, if we go to the application, let's stop this and do watch. No, I'll keep it with run because I want to control this right now. So let's start. Sample group. Another sample group. Okay, but this was what we had. Sample group edited. Something happened. Why did the order change? Let's go here. Weird. I have no idea why the order changed. Okay, but there is something to keep in mind. By doing this, like we have right here, like this, the order is what the database wants. So if we want to be sure to have it like for in the order it was inserted, we can do order by y dot id. This way we are sure we have the order we want. So it will be always this. Okay, so, and like you saw, we restarted the application and the values are still there. Of course, we are using a database. So finally we got rid of this we can get rid of this. Let me just clean up. So startup, business, can get rid of this, and we have only this. So what next? What can we see? Okay, probably other variations of the update are interesting to see. So other ways to do update. This is the simplest one. 3 lines, pretty good. Another way would be, let's create wait. Simplest update, I think. Copy this here. Basically, this will be that. Okay. Now other ways. Maybe the classic way of doing it is probably going to and then, well, we just update, so then we could dot name oh, I forgot to wait, and then we would say, do something like that, which is kind of not great. In this case it's not that bad because we only have one property, but if we had more it would be a bit more troublesome. So another way that would be easier would probably be, how is that? So we fetch it, but then instead of doing it like this, we can do context.entry existing group, then current values dot set values group dot to entity, and in this case it will update all the values, so it will always be these 4 lines even if we had more than just the name. More stuff. Okay, so these are a couple of ways. This way I'll just put it back in where it was. I'm not going to commit these changes, it's not needed. But another way we could do this like I said, doing this update like this, we may have problems because of the entity would be already loaded. One way to avoid this is, for instance, to try to get the entity before. So we could go to our local group and go to context.groups.local and then single or default. So like this, we are not making a query. We're just seeing if in the current DB context we have this already loaded. And if we have, we can do a lot of things. We can update it directly instead of doing this, or we could, for instance, do local group dot context dot entry local group dot state and detach it. So by doing this, we take it out of the context and then we can add a new one. I don't know if it's the best approach, but it works. So we have this bunch of options, but I will keep it simple because, like I said, it's not very likely that this will be a problem, but if it is, you have some options to try and avoid it. Let me see what we can talk about next. One way of avoiding this problem and having other benefits is to do something like this. We go to the DB set and do as no tracking. So what this does is the result of this query is not the entities that come out of it are not tracked in the DB context. So in this case, when we update, it will not be there. This is a way to solve this, but probably not the best one. The best one is maybe check if it's already in the context and stuff like that. But this is really helpful for another reason, is that it improves performance, because by not tracking, we just get it from database, map it, and it's good to go. Because we don't really need to map it, so we can do for these kinds of operations, which is we want to get all to return to the front end, we want to get one to return to the front end. No reason to have the entity tracked, so this will improve performance. If, for instance, before doing the update, we would fetch the entity to then update it, in that case we wanted it to be tracked, so we shouldn't use this. But in this case, in these two methods, because this is just used to return to the front end, as no tracking is really a great option to improve performance. Let's take a look at another interesting feature we can use with Entity Framework Core and Entity Framework before it, which is to use concurrency tokens for optimistic concurrency. So what does all this means? Basically, imagine this case. Let's comment this part and let's do it like the other way we talked about. So our existing group equals await we have the group, and then we'll do the, like I mentioned, the name equals group name, then you await return the existing group dot to service. Okay. Imagine we do this. From the time we get it to the time we make the change and save it, another person could change this. So let's do something like I'll put here an await. That's dot delay. And want to delay 10 seconds. Before that, let me just prepare a query over here. Update. What do you want to update? The groups. Set name equals it's a terrible name, but okay. Where ID equals 2. Okay. And no, we need something else. So we go to group mappings. No, not this one. Group entity configuration, and we'll say builder. Let me see. Use and this. This is specific for Postgres, but you can do some similar things with SQL Server. I will talk about them in a moment, but let's just see this in action. So xmin, it's a column that exists in every table in Postgres that's incremented every time the row changes. So we don't see it here. Maybe there's a query to get it, but no need. So by doing this, there will be a new column mapped to the entity, and will always be checked when doing an update if the value is the same. If it's the same, it means that the value that was fetched on this moment is the same that's in the database right here. If it's not the same, it means someone else changed it, so we'll get an error. So let's see this happening. I think I need a migration for this. Let me stop this. I'm not sure the migration is really needed, but if I run this, it will create one, so let's do it. Let's create one. The reason I'm not sure the migration is really needed is because the column is already there. Although the migration, if we look at it over here, it says it has the column and all that stuff, but the column is already there, so I think the Postgres provider will ignore this, but it doesn't do any harm to be here, so let's let it be. So make the application run. Let me just put data grip closer. Okay. This is working. One interesting thing is seeing all this. We can see the queries. And now we'll edit this group. and we'll do this. We'll save. This will take a while, so let's run this. We'll update. And hopefully this will go kaboom. And it is kaboom. So db update concurrency exception. Let's see why. When the update command is run, if you notice, besides what we did here, this update set stuff, in the where, besides the ID, it checks that the xmin is the same as is provided. So if it's not the same, we get an error because it means it changed in this little time. In this time, 10 seconds, which I can remove now, it means it will fail. So it's nice to use it this way, but this can be even more useful depending on the scenario if you want to do something like that. But it can be more useful, for instance, if we have multiple people changing it, and the problem is not really just this part of between this and this, because this is really normally would be a really small time, and people would just retry and see that it changed, and don't see that it changed. They will just retry, and yeah. So it might be more interesting to, for instance, while this is open, let's put imagine that while this is open, someone changes. This is not detected by the way the concurrency token is implemented right now. It will only detect an error between the first get and the last update. But what if we have this open and another person has this open and changes it? We won't get any information. So we can do some changes to the group, to the concurrency token that we are using to be helpful in such a scenario. For this to be helpful in these scenarios, we can go back to the original, because that way of doing it was important for the current way we are doing the concurrency token, but we are going to change it for a much more interesting scenario. So so let me check the cheats, because this needs something. Where is it? Okay, so we don't want this. This is just that simple scenario, which is important. That way of doing things avoids us to have more locks in the database, because if we do it like that, we can, as most of the times it will not happen, we can just use optimistic concurrency. If not, we had to go with more locks, like different isolation levels, and maybe write locks on the entire table to avoid other people to change it, which isn't really good nor scalable. So this optimistic concurrency, because most of the time is good enough. Yeah, it's good enough. But like I said, it doesn't cover the scenario where people are changing in parallel, and maybe they don't want for it to override of one another. So to do this, we'll go to the entity. Where's the entity? Go to the entity, and we'll add a new one. Public. Let me check just one thing. It's an unsigned integer. and we call it row version. And we go to the configuration and do as column weird. Property row version as column name, which is xmin, which is that column I talked about, as column type, which is id, we say that value generated on add or update, which means the database takes care of that, and we say that it's a concurrency token. Okay, if you want to check out mostly where I got this from, if you go to build.for-npg, if you go here, let's see the source, it's mostly here. The difference is that instead of having a real row mapped to the entity, it's using one of EF features, which is shadow properties, which means it will use this xmin, but it won't be mapped in the entity, so we can't use it directly. We can use it in some other ways, but we can't use it directly. In this case, we don't want the shadow property because we want that property to go to the front end, so we can pass it back when we update it. So I'm basically doing this. If you notice, it's basically the same, with the only difference that I'm mapping to a property that exists on the entity. So doing this, now we need to put this in the business property, in the business entity. So I'll create here, I'll put a string here, just because that being an integer is really specific to Postgres. If we are using SQL Server, it will probably be a byte array. So it's better to, I prefer at least, to put a string and then convert it in any way. So now when we do the group mapping, we can do row version equals string, and over here row version equals model dot row version. This isn't very safe because if you pass something that we shouldn't, this will blow up. Let me just, it's better to do it another way. safer to do it this way. So we have this mapped. Now we also need this to go to the front end. So we head to the models, and go to mappings. And the same here. And we go to the view, the tails, and we'll have a input, row version, type hidden, okay. So when we get, let's just see it working. So now if we do this all working normally, let's edit this. But before that, we'll go to here, check the form, and check that we have a row version here, put hidden value 565. Let me just make a change here that's interesting to see. I think it's over here. Enable sensitive data. One thing that you might notice is that in these queries we only see the query and not the values, which is good because we don't want those kinds of values to be in logs. But because we are only testing stuff, we can do this, enable sensitive data logging, and the values of the arguments that are passed will be seen instead of this stuff. So let's start again. It also warns because we shouldn't be doing this, but let's check here. Now we see that the fetch used 2 instead of a question mark. So another group, edit it. Row version is here, 565. If we go here now, here, and we do an update. Now we did the update before clicking save. Now let's click save. Kaboom, concurrency exception. So now we see that argument 2 is 565, but if we go back here, the row version 566, so it was updated during the time the Windows is open, and now it fails. This may not be interesting. Maybe we just want to overwrite what's there, or maybe we don't want to overwrite and we want to alert people that they changed something that someone else changed while the window was open. So I think this is really interesting. And now if we are sure we want to update it, now Now we updated it. Okay, so this depends on the situation, as most things. But if we have that situation where people may change the same thing and don't want to, this is a way to avoid it. Just one thing that's maybe important to add in this case, because I didn't know about it and discovered while making some tests. Let's go here, let's see something. Yeah. If we do it this way, now this doesn't work because it's doing the name only. But let's do the other way that I talked about, the context dot entry, no, context dot entry, existing group, entry dot current values dot set values, group dot to entity. One thing important to notice is if we do this way, then let's make a test. Run. Okay, so now if we go here, it's open. Now we do this. It was updated, but now if we saved, let me just check. If we save, it will work. Apparently, when we do it this way, we must do entry dot original values and set the value I don't remember. What was that way? Let me check if I wrote that in the sheets instead of wasting your time. No. Okay. So we must go to entry dot property original value equals this. This, no, this. Don't know why, but apparently, or it makes sense because we are setting values to the current values, but the original value is what's used to make that check in the update. So we need to do it this way if we go this route. So another reason why this one is simpler. It does everything in one go. So now if we go here, we want to put another group. Now we get an error because it's setting the row version correctly to be checked. So if you do it this way, like fetching and changing, and want to use this strategy for concurrency, not only the simplest one that is just between those invocations, that's important to keep in mind. So with this, I think that's about it for this episode. Like I said, this isn't a massive walkthrough on EF Core. It's just putting it to work with what we have so far. And in the future, we'll surely add more things, like the group will have players, and then we'll play around with having more entities connected, tables with foreign keys and all that stuff. But right now, this is what we needed to do. So we have it, and we'll be back in the next one to continue improve on the solution. Hope to see you then. See yous.